Let me give you a brief on the kind of the webinars that we are going to have today. The webinar that we are going to have today is primarily focused on the people who are into let me give you a brief on the kind of the webinars that we are going to have today. The webinar that we are going to have today is primarily focused on the people who are okay. Actually, technical difference. I did the YouTube live and the echo was coming. So now it is better now. So what we are going to discuss today is this is an initiative by my company, Advanced Engineers, to provide the knowledge for the people who are into the industry and who want to learn more about industrial automation, where the automation can be used, where they can actually have a better growth prospects also. So today's webinar, which is on Saturday, is primarily focused on the people who are actually working already in the industry. They do have their own understanding of the basic industry experience. They do have some kind of experience working on some kind of application they have. They might be having some challenges also in their daily day-to-day work. We do have another webinar which is basically done on Sundays, because today is Saturday. Saturday is for the people who are already working on automation. Sundays is not for the people who are working on automation, but it's for the fresh engineers. So the engineers who are actually trying to create a career out of it. So we are trying to put two things in a different perspective. Today we are focusing only on the technologies, how the technologies can be implemented, where it can be implemented, what are the reasons for those technologies in the field. So this is the whole idea of today's webinar. Sunday's webinar is more on the basics, that if you want to get a job, then you can just start on this. So to start with, I would suggest that we have a few people in the room who can actually start with the introduction, because we have already 3 minutes past the starting time. So what we can do is we can start with Kamalji ji. You can just introduce yourself just in 30 seconds, that what do you do, what kind of experience that you have, or if you have any kind of challenge in implementing industrial automation, or you have some kind of a thing about that. So just 30 seconds, your name, what kind of the work you do, or any challenge that you're facing. So Kamalji ji, start with you.
Good afternoon. I'm Kamaljeet Singh. I'm a retired scientist. I was working in the field of industrial production, reporting to paper, cement, glass, and leather industry in Ministry of Commerce and Industry, Government of India. Some of these industries, particularly cement and glass, they are slightly better in automation area. But paper is one industry which is dear to my heart. But then very poor automation is there. So that's how things stand as of now. So I am, though retired, I am still active in the field and working with MSMEs also.
Great, sir. Great. Thank you, Kamalji ji. Your energy is really, really contagious. So whenever I speak to you, I really feel motivated that even after getting retired from a formal career, you are still not retired. And the person who loves his job will never retire ever in the life. So we need people like you to inspire us to add on this. And you said that you have not seen much of automation in the paper, but sir, in the last few years, the paper industry has also gone for a sea change. If you go 20-25 years back, we were not having enough people in automation in the paper industry, but now we have got very, very experienced people running the paper industries also, because as any business, this business also needs proper compliance system, safety systems, quality systems. People pay you for your compliance and quality. So all the companies around us, particularly I'm based in Chandigarh, so around us in Chandigarh, we have Khanna Papers, we have got Trident Papers, we have got Quantum Papers, Setia Papers. These are the paper companies which are around me. Now they are quite automated now, although they started with the paper machines first, because paper machine was their bread and butter. So they started with that, then they put in the pulp mill, the de-inking units, even the ETP. So now they have moved further from the old systems. But yes, still lot is to be done, because paper industry is still controlled by very, very few individuals who have got the conventional mindset. So definitely this industry needs to revamp and come at par with the other industries that you have already spoken about, steel and glass. So definitely, thank you for your inputs. Now I would like to request Pratush Gupta to please unmute yourself and tell me about what do you do, what kind of experience you have, or you have any kind of challenge in automation, or you see any kind of challenge that can be addressed today. Pratush, you can unmute yourself and speak now.
Good afternoon, everyone. So my name is Piyush Gupta. So I belong to the automation industry, particularly work in the food and pharma, food and beverages and pharma industries. So uh, I see a particular different kind of challenges in the automation industries. I think people are not much aware about the industry, or particularly regarding the automation. So they need to be more educated themselves regarding the automation, what kind of automation is, and how deep we can go into the automation. So I see that one of these kind of challenges, particularly for the automation.
Very true. Thank you, Pratoshji, for giving your perspective. This is what we have seen in the industry. Like I am into the business for the last 30 years. I have seen the industry, sometimes they themselves are not open to accept that there is a problem. So you have very rightly said that we can go very deep into anything that you want. But the crux of the problem is that, first of all, accepting that we do have a problem. So automation is not a solution of all the problems. Definitely, it's always a problem that you have to address as a solution provider. So industries are going ahead with the automation on piecemeal basis. They don't go on 100% that they want an automation. Sometimes they do overdo in the automation. I have seen some companies investing too much into automation, which has actually complicated things at a later date. And there are a lot of companies who don't even try to start with automation, just fearing that tomorrow if they put an automation, they will have to hire very senior people, they will have to invest into lots of systems over there, which is a myth, because most of the companies which I deal with, particularly the big MNCs who are there, they are very clear on the automation, because the automation is such a field which actually improves your operations, it improves your money part, it also helps you to improve on your quality and compliance system. Based on that, you actually get paid for your product. So this is something which can be a good hard earner for the companies, and that's the differential that we have seen. I see another name of Mr. Ramesh Kumar. So Mr. Ramesh Kumar, can you just introduce yourself? You are from which place, and just let us know if you are looking at any kind of challenges in implementing an automation in your field and what kind of industry you are. Mr. Ramesh Kumar.
Hi, sir. Good afternoon. I'm
Good afternoon.
Ramesh. I'm from Tamil Nadu. So I'm working in a system integrator side actually. So we do PLC and LV switchgear panels. So mainly we are working with Siemens and Rockwell.
So, Ramesh, thank you for your input. This is exactly the webinar that you should be part of, even your customers should also be part of. Here, what we are talking about is primarily the challenges of the industry today. And I would love to have a feedback from the horse's mouth, like the people who are actually using it. So we do have having more people coming and joining us on a regular basis. Today is the first webinar we have. So we will be keeping it very simple. And I'll start straight away with my presentation. Just if you allow me to share my presentation. Just a minute. So can you see my screen, please?
Yes, sir.
Okay. So what I'm going to do is I'm going to move towards the presentation part first. So is the presentation visible now?
Screen is visible, sir.
But
Not
the
present.
presentation is not coming up. Okay, just a minute. Let me change it to, thanks. Give me a minute. I hope now the presentation is visible.
Yes, sir.
So this is the first question that I normally ask in the front to all of my audience. And first of all, are you ready for the automation boom or you want to be left behind? Because this is something very, very close to me, that whenever you talk about automation, everybody is excited. Everybody is excited that we should be having automation. We do have our own cars, so we want the automated cars. Okay, we do have lots and lots of things. We run lots and lots of app on our mobile phone. We everywhere we want the automation. Okay, we want to be part of that automation boom. But as soon as it moves into the industry sector, we see the people are reluctant to go for an automation. So this is my question in the beginning to everyone is always that, are you ready for the automation boom? And I want everyone to say yes, because that is the way the context is going to be set. I know there will be the people who may not be ready to be part of that automation boom because of their own perspective. They want to be left behind. I have put it as the negative word of left behind. Is the reason being is that I wanted that they should feel that the automation is going to be the way forward. If you don't talk about automation today, you don't want to learn about automation and you don't want to implement that automation, it's going to be a problem in future for you as an individual also, because everyone has to learn automation in one way or the other. Moving further, I'm just setting the agenda. We will be covering around, taking around 30 to 45 minutes of this whole entire session. And here we are going to talk about what is the current industrial reality. And I'm also going to cover the skills that pay. I know lot of you people are actually might be employed somewhere. You might be working somewhere, or you might be into a business, or you might be implementing your technologies. I'm linking directly hard hitting it with the skills that are actually going to pay, because nowadays there are big challenges of even the pay also, and it's a demand and supply gap which is coming up. Then I'm also sharing you the career roadmap that you can create for yourself, and definitely the mistakes to avoid. And in the end, we are going to keep it under QA. And if we have some time, we will be definitely covering one or two industrial topics also. So we will start working on that. So moving further, I'm just going to introduce myself. My name is Manmeet Singh Bhatti. You can Google me. It's very easy. My life is very open. So I'm an instrumentation control engineer. I passed out from a college by the name of Regional Engineering College, Jalandhar. Nowadays, it is being known as NIT, but I passed out in REC, so I still call my college as REC. But yes, nowadays, younger generation call it as NIT. So I passed out in instrumentation and control engineering. And at that point of time, the instrumentation control engineering was a very, very new branch. In fact, I was from the second batch. So nobody even knew what is instrumentation and control. And we had to struggle in the beginning to actually get our first job. So I had to struggle almost for 2 years to get my first proper instrumentation job. Before that, I studied in that college. We were trained by the best of the people available at that point of time in instrumentation, but those guys are more of like either chemical engineers or electrical engineers. But we never had that liberty of learning from the instrumentation engineers. But yes, we learned well and we used that. So I moved from, once I got my degree, I moved into the automation industry. So I also started my career working with a system integrator in the beginning. So I worked for 2 years. I did the wiring of the panel, did the programming of the PLCs and all that stuff. That was the way you start your career. But from there, after 2 years, I got into the companies by the name of Forbes Marshall. I worked with Forbes Marshall for a few years. From Forbes Marshall, I moved to Honeywell. So Honeywell is again one of the biggest companies in the globe level for the automation. And from Honeywell, I moved with a company by the name of Rockwell Automation. So I moved to Rockwell Automation. That was my last company where I worked. And in 2011, I moved to Advanced Engineers. This is a company which I founded. And Advanced Engineers is primarily a company focused on industrial automation and IoT. So this is what. So what I learned in my college, I actually got into the same job. And whatever I worked in the job, I actually started to work in the automation field in my own company, in my own business. So I have got more than 30 plus years of the experience only in instrumentation. You will find very few people purely working for instrumentation and automation for so long. We have people nowadays getting the jobs in instrumentation control. Earlier, people were not having enough jobs in industrial automation and instrumentation and control. I'm also a TEDx speaker. I'm also an author and mentor. My book, Job Hunting Reimagined, is a bestseller in Amazon. So you can just Google it and try to find it out. If you want, I can always send you a link to be part of that community, and you can get that book also. There, what I have done is I have tried to help the fresh engineering graduates or the people who don't have a perspective about industrial automation to actually understand what is industrial automation. They should be able to learn it, and they can actually crack their first job by learning that. So I never had anybody as my mentor to do that, but that is my book which I have given to my community. If you have any questions in between, you can just unmute yourself. You can ask. We don't have too many people in the room, so we can ask, and you can get the answers anytime that you want. Moving further, now, why this webinar is very, very important is, first of all, most of the engineers, even if you are employed into an industry, any factory or anywhere, you still are not industry ready. So industry needs engineers. So what they do is they simply hire the engineer, they let them work, they give them some jobs, they get some sort of training, but the actual learning is actually on the job. So whatever you want to learn, it depends on you, that what kind of time that you want to spend in, what kind of the risk that you can put in, how many times you want to make mistakes over there to learn it on the job. Here, what happens is, we are human, we have a human mind. We actually don't take chances, because on the shop floor, it's very, very difficult to take chances. So even if you have got a job, still the 90% of you may not be fit for that particular job. So that's why to stay in this webinar till the end is very, very important. Next is automation demand is rising. This is going to go up again and again and again every year. I insist on this. Learn automation, because in future you will find everything automated. The people who are actually not learning automation may not be able to grow. Imagine a scenario just 20 years ago. I had some people, when I used to tell them learn something on coding, people never used to do it. I used to tell them learn to operate a smartphone or a laptop. People never wanted to learn it. Okay, they are happy doing it. But last 5 to 10 years, we have gone a sea change. The people who are senior to us or who are aged to us, they face problems to cope up with the technologies. The growth happens only and only if you keep on learning. So lifelong learning is very, very important. So I always recommend that you should learn everything. You don't be master of everything, but you should be aware of everything. That's very, very important. Then we have a skill gap. It's very, very clear. We have got one gentleman who is working with a system integration company. I'm very, very sure you must be facing problems of not having skilled people in your organization. You must have seen your clients also not having properly skilled people to run their own their operations. Maybe not, I'm not talking about automation. I'm talking about any kind of things. You don't have proper electricians, you don't have proper welders, you don't have fitters. That's a big problem. And with this skill gap also brings you an opportunity. So if you start learning on something today, definitely it's an opportunity and you are going to grow with this. Moving further, now I'm covering a little bit of the market insights, why it is important, why you should even put your money or your time into this is, first of all, the global market has gone more than 200 billion plus, and it's growing regularly. We don't have proper manpower available nowadays. India used to be called as a country of cheap labor. Now tell me, looking around you, we have got some people from Punjab, we have got some people from Haryana, we have got gentlemen from Tamil Nadu. Looking around you, how many people are there in the labor jobs? We don't have enough labor jobs. Physical labor people are very, very few. We have got the people into the white collar jobs. We have got people who don't have a job, but they have got a degree. But you will not find the people who are actually doing the actual jobs. Actual jobs means machining, fitting, welding, drilling, wiring. Very, very few people. One opportunity where the automation is going to help. Industry 4.0 is growing like anything. In fact, now 4.0 is also obsolete. Now the people have moved with the industry 5.0 with the collaborative robots and all those things. And it's growing by 8 to 10% every year. It's a huge, huge opportunity. The market is growing. You should be part of that. It's a rail which is moving very, very fast, and you can actually be part of that, and you can actually have a secure career. India, after the COVID, the whole world has actually moved away from the manufacturing which is being done in China. People have moved, and they want that other countries should also be capable of providing the services. And that is one of the reasons that most of the big manufacturing is also making bases in China. They are not shifting from China at all, 100%, but definitely they are putting their second money in India. So the Indian manufacturing is also going to go up and up, up and up. So this is the right time to learn about industrial automation. Now, where the automation is being used, you talk of any industry, it will be there. So if you are from pharma, if you are from food industry, even oil and gas, power plants, even from any kind of manufacturing, you will find some kind of automation. The least automation that you can talk about is like in some construction, even they are nowadays automated. So they are having their machines, they are automated. You have got the lifts, they are automated. Even the water pumping stations, RO plants, they are all automated. So automation is making its inroads into all kind of segments. Core technologies to cover over here is, first is the PLCs. People talk about PLCs that we want to learn on the PLCs. The thing is, they need to understand, first of all, what is the PLC. The programming is never going to let you grow. So don't become a programmer. Be a process expert. Understand that how the PLCs work instead of programming the PLCs. That's number one. Then we have got a SCADA. So SCADA developers primarily is a software operations, but software are being operated by the basic operators. They are not being operated by very experienced people. So it's very, very important that your SCADA skills should be very, very intuitive. The way the color combinations are there, the way the positioning of the buttons and everything is there. It should be very, very clear. I have seen SCADA engineers struggling that they are not able to understand the color codings. They are not able to understand the intuitive method of human mind, that how the operator is going to work on that. So sometimes they are dependent on the user. And most of the time we tell the user that you give us the drawing and we will create a SCADA for you. So entirely other way. If you learn the people behavior, how they behave, how are they going to do that, how the emergency is going to look like, how the operations are going to do that, just try to learn on those psychology part, you'll be a better SCADA engineer. Then we have got sensors. Definitely without sensors, nothing is going to move further. You need to know what kind of sensors are there, what is the accuracy, how it works and all that stuff. I'm not saying you will be able to learn it in a day. It will take time. But keep on learning. Everything, wherever you are sitting today, you must be having one temperature sensor around. You must be having some kind of a flow meter around. You must be having some kind of even if you're in your office, occupancy sensor is also there. Electrical meter is also there. These are all sensors. Just whenever you see a sensor, just try to Google it, take a picture and Google it, how it works. I can assure you, I improved on my English. I had a problem with my English. So what I used to do is, whenever I used to read any kind of a word which was a difficult word, I used to note it down on my notebook. And whenever I used to go back to my home, I had a dictionary. I tried to understand that what it means, and then I tried to read articles on that particular thing. So that is the way the vocabulary improves. Same is with the sensors. Your knowledge is not going to improve by just reading some books. Whenever you see a sensors, either take a picture of it or either understand that whatever it is doing. And today you have got Google to help you. Today you have got ChatGPT to help you on that. So look at it, read on it, and try to understand it. So whenever you are looking at that sensor again, you are already aware that how it works and how the signal is going to work. So that you should be knowing. Same as the VFDs, variable frequency drives. These are the electrical actuators of your motors. So you need to learn about it, because in automation, VFDs are coming up. Now, one more part is the industrial IoT. This is something which is very, very new in the industry. Although IoT is being used by other industries on a regular basis. In automation, we have just started to work on industrial IoT. So this is one area where you should be definitely, because in future, as I'm saying, the automation is going to come in future. You are also going to get industrial IoT by default. So you need to learn on this. Just a minute. I, by mistake, actually changed the slide. Okay, so moving further on this, now we are now going to do a reality check. These are the three things that happen with best of us. So whenever we go to the college, we learn the theory. So we understand theory, how the college is telling us. We have got some labs, but 90% is always the theory. We don't get that practical exposure that you want. Even if you get a practical exposure, it's normally spoon-fed to us. There is a project which has already been given to us. We just simply make it, copy, do the wiring and do it. That's what we do. So it's good for having a feel-good factor, but it is not teaching us anything. Industry actually gives you those applications. You learn on that. But in industry, you learn sometimes the hard way. It's not so easy to learn on that. And that difference is actually called a career struggle. So even if you get a job today, you start working on that, but you are actually full of theory. You don't have a practical thing. And if you don't have a good mentor or you don't have a good friend who are senior to you, sometimes it's going to be a challenge for you to actually grow in your career. Sometimes you have to struggle and you have to learn the hard way. So this is the reality for most of the people. This is what I've seen. So it's always better that you learn maximum in your college, have better internships, go to the industry, learn from the experts, have few people who are your mentors, just follow them, how they work, ask them the questions. I can assure you, the people who are good mentors, they will always be there to help you. We sometimes feel that if I ask a question to some so gentleman or lady and I don't know them much, they will not be answering. It's not the case, my dear friends. Whenever a person is a mentor, he's always a mentor, even if you are meeting him for the first time. So always ask questions, learn from their experiences, even learn from their mistakes. Moving further, top mistakes that we do. As I said, we learn primarily theory. We don't focus on the practicals. It's very, very important. One thing that we miss as individuals is that we don't have a roadmap. We never have a roadmap. We just have some kind of a wish list. So we have a wish list that I want to learn PLCs. We have a wish list that I want to do this. We have a wish list, but we don't have a roadmap. So I would recommend that all of you should be creating a roadmap. If you have got a notepad with you, if you have got a mobile with you, I would suggest that immediately write something that you want to be in next 1 year and look at that particular thing. It could be anything, like it could be a career, it could be money that you make in a month, it could be you want to buy a good car, or you want to buy a house, or you want to buy something which is very, very close to you that you want. It's very aspirational, whatever it is, just write it down. As soon as you write it down, I can assure you, your mind will automatically give you a roadmap. If I want to go to, say, I want to scale Mount Everest, I need to first of all think about it that I want to scale Mount Everest. Problem comes is that we don't have a goal. And when we don't have a goal, we don't have a roadmap. Most of the time, we just have wishes. I wish that I should be getting 2 lakhs of salary. I wish that I should be getting 20,000, something like that. So those are the wish lists, and God never gives you for the wishes. It actually gives you for that you really, really want from your heart. It should come from the center of your heart. It should always be with your very open mind. So you have to get into that. So I request that you please make it. And once you have written it, just confirm it in the chat box that you have done it. Please do it now. So if you have done it, just give me the chat in the chat box that yes, you have done it. Just your target in the next 1 year, that where you want to be. I can tell you, it's very, very important that if you write it now and you look at that particular thing on a day, first thing in the morning and last thing when you actually sleep or on your bed, you may not have to wait for full 1 year. That particular target might be achievable within the next 3 months, 6 months. God has got a different ways of doing things. I can assure you, you will be able to reach that target, whatever it is. It might be ridiculous also, I can tell you. Sometimes I have seen people putting very, very ridiculous thing or very, very ridiculous number. I have seen those things are also getting achieved. It may take another 1 year, no problem, but things will start moving. People will start thinking about it. When you think about it, it's called the power of manifestation. There's another session that I do for the manifestation, but today we are talking about this. So I would request that you please have something written for this so that your mind automatically creates a roadmap. Although I'll be giving you a roadmap also, how to go for it, but you will be able to see that it can be done. Okay. Now, moving further, we also don't do any networking. This networking is not that engineering networking that we connect the dots and all that stuff. Networking means we engineers are the worst networker in the world. We do have best of our friends with each other. I have got hundreds of friends, my batchmates, my hostelers, my seniors, my juniors, and all those things. I love to meet them. I love to party with them, and I enjoy with them. But I don't discuss my business with any one of them. This is the truth. I don't discuss my problems with any one of them. Always have a network. And this network doesn't mean just your friends. The people who can help you to grow. The people and help you to grow doesn't mean that somebody gets you a job or somebody gives you 1,000 rupees, 10,000 rupees, you just buy it or something. No. The people who can add value to your life where you actually can reach to your goals. It could be anybody. It could be your mentor. It could be your parents. It could be your brother, sister. It could be your boss. It could be even the guy who is getting a cup of tea for you. Same day. So they can also be the people. But keep on networking, meet people, ask questions, appreciate the people. Whosoever you meet and you ask questions and appreciate them, you will see learning happening over and over. Very simple question. You can ask the person who is making tea for you, what special you have made in your tea. Okay, today is good. All those things. So you are actually going to do those networking. So make sure that you do the networking and waiting too much. This is something which is, I have been culprit of that. We want the things to happen and then we wait. My dear friends, it's simpler to wait. Okay. It's very simple that you don't do anything. We will wait. Okay, we will do it tomorrow, or this thing will be coming to next month, or within 2 months, so it will automatically be coming. It never happens. You will have to swim towards that place. So don't wait. If you want to do something, start today itself. You want to try something, start today itself. You want to fail something. There is a program in the Innovation Mission Punjab where they actually train the startups. So anybody who is into startup can go and register with them. And the first program that they give is not that how to run a startup and how to get money from VC and all that. The first program that they have is called the Fail Fast. So what they do is simply they will tell you to bring in your idea, discuss on that, and make sure that that idea fails. Okay, it's an entirely different way. My friend is over there who trains them. I see that the Fail Fast is one of the best programs ever created. Because as an individual, if you know that this thing is going to fail, you don't have to wait for 2 years or 3 years to fail. You just know that it is fail. But I tell you, 90% of the things, they actually don't fail. You just know where it is going to fail, and then you find a solution and then you move further. So these are the mistakes that we do. And moving further on this, now this is a roadmap that you should be having. Okay. So I say, I have covered up to 5 years, although I can cover up to 25, 30 years also. That is not a problem. But today, I'm just sticking to this. Always have first 0 to 1 year. So 1 year, you have to do the maximum. You have to do the maximum heavy weight exercises in the first year. You will have to do everything. You may have to do the wiring of the panels. You may have to go on the pipeline to install some flow meters. You may have to go for calibration for something. You will have to do the heavy lifting the first year itself. Be prepared for that. Problem happens is people join a career, but they don't want to go into that grind. Unless you don't get into that grind, you will never be able to pick up the cup where you will be involved in the projects. So between 1 to 3 years, then you move into the projects. You start creating something. So whatever the project that you get, you go for a PLC programming, you go for installation, you go for a SCADA system, anything that you want to try. That will be coming in the 1 to 3 years. So for the first year is the heavy lifting. 1 to 3 is start working on that, honing your skills on the project. Between 3 to 5, then you get into a specialization. It's very, very important to miss on it. What happens is people get a career and they start working and then they start going with the flow. Not at all. Make sure that if you have enough projects under your belt, after third year, you start specialization. Imagine, I give you a simple example that you are a PLC programming engineer and what you are doing is you are actually moving, you are actually doing programming for, say, oil and gas industry. Okay. Or you are doing programming for, say, pharmaceutical industry. These are the two sectors, totally different sectors. After third or fifth year, I would recommend that you move into a specialization in pharma for 21 CFR Part 11 compliances.
or you move into something like a cybersecurity of the SCADA systems. These are very, very specialized jobs. You will be paid very highly for that. Same way, oil and gas, you can go into the safety PLC programming, you go into the process PLC programming and all that stuff, or networking, something like that. Get into that high-end programming. You will be paid more in this. This is the way it works. But the problem with the normal people is that, first of all, they don't do much in the first year itself, and they have got some small experience within the next 3 to 4 years, and then they stick to that particular thing that this is a regular grind. My dear friend, that is not there. After 4 years, 5 years, you should be having a specialized mindset that people should be looking at you that this guy is not just an automation engineer. He is an experienced guy who can deliver 21 CFR Part 11 compliance systems. Or this is the guy who can deliver a top-notch safety shutdown system for an oil and gas industry. Okay, that is the way you should be. It's the perception that we have is that anything that comes is automation, we can do it, we'll get money, we'll get paid for it, we should. Imagine a scenario, you have got a doctor in your village who is a RM, we call it registered medical practitioner, RMP doctor. His fees is not more than 100 rupees. Then we have got an MBBS doctors. MBBS doctors, the fees will vary between 500 to 700 rupees depending on the kind of a doctor he is. You go to a specialist, they charge you 1500 to 1700 consultation fees. You go to super specialist, they will charge you 5,000 rupees a consultation fees. That is the way the things go. So this is what you have to be very, very clear on that. More specialized you are, the more relevant you are, the more demand is going to come. Problem is that we always want to be general. So we work on the general things and we stay general thing. Then we complain on that the people having an experience of 10 years is still being paid like a person of 5 years. So that is what is going to happen. So I will tell you that don't make that mistake. Make sure that you go through that same grind. Now, this is the salary growth I want you guys to know. What happens is, at the first, you just get a salary of 15,000 to 30,000 based on your experience, based on the kind of the level that you have, based on your presentation skills, based on your own technical skills also. You will get somewhere between 15 to 30,000. That is what that expenses and all those are separate. This is the standard Indian market rates, I would say. I would not say rate, but salary for an individual who starts his or her career in industrial automation. But then he has to move into the skills. He or she should be able to hold those projects. As soon as he or she is starting the project with experience of 2 years, 3 years, 4 years, they move into a salary bracket of 50,000 to 1 lakh. Okay. So the salary actually grows within 2 years, 3 years. But the real jump will come after 5 years if you are into a super specialty job. If you are into, like you are a programmer for safety shutdown systems, you will easily be paid 2 lakhs plus. Very, very simple. This is just a basic thing. So I would recommend that you take a snapshot of this particular thing, that if you focus this way, you create your route like this, you will definitely be paid like this. Any questions on this? If you have any questions, just let me know, or you can unmute yourself, or you can just chat and you can just do that. Okay. Now moving further. This question I asked from in the beginning. So what I'm going to do is I'm skipping this presentation to a little bit technical presentation that now we should be doing it. And that presentation is, I'll just make it open for you guys. Okay. Hopefully my screen is visible to all of you. Okay, my screen is visible. So now what we are doing over here is, I'm going to talk about a very simple technical point, which is called 4 to 20 milliamperes. I'm sure you must have heard of that. All the signals, analog signals are 4 to 20 milliamperes. So we do that. Anybody who is not aware of that analog signal is 4 to 20 milliamperes can let me know. Okay, now moving further over here is that all signals in the field are always 4 to 20 milliamperes in most of the cases. Now, what is 4 to 20 milliamperes? But we need to understand that this is the loop, or this is the physical signal. It actually goes to the final control element, or it comes from the sensor to the controller. So if you see the slide in the center, we have a controller, or that controller can be a PLC system. It can be a single loop controller or anything. it gets the signal from the field. See, this controller is nothing, it's a glorified computer. So computers, they work on digital functions, 0, 1, 0, 1. That is the way they are going to calculate, they are going to work on this. So field instrumentation gives them a signal. That signal is 4 to 20 milliampere. This controller wants to control that particular flow through a valve. So valve also get a signal that is 4 to 20 milliamperes. So the entire loop is at 4 to 20 milliamperes. That is the way it is going to work. Okay. Now, this is the first question that people ask me, is that we do have option of 4 to 20 milliampere also, and we do have 0 to 10 volt also. Most of the people who are working in the VFD industry, they do have that. We have a signal of 0 to 10 volt also, and sometimes 0 to 5 volt also, sometimes they are using it. And as soon as they move into the field instrumentation and all that stuff, the signal moves into 4 to 20. So this is very, very important that we need to understand that majority of the sensors that they work in the field who are moving into sensors, when they move into something like field, they always give you a milliampere signal. It's always a milliampere signal. But whenever there is a transducer, any kind of the transducer that most of the signals are actually coming in the form of voltage. Okay. So any transducer, you give it some kind of a current, it gives you an output, and that output is mostly voltage. So majority of the transducers, they give a voltage output, or they actually change the voltage of the electronics. So that is the way. That is the way it works. Okay. But why the industry standard is still 4 to 20 milliamperes? This is very, very important. That industry standard is 4 to 20 milliamperes because of this reason. Okay. So first of all, 4 to 20 milliampere can go to a very, very long distance. So if you see on the left side of the screen, you have got the voltage is being generated by the sensor. So 0 to 10 volt is just a number. It can be anything. It can be change in the voltage. It can be change in the resistance. It can be change in the temperature, whatever it is. But it generates some kind of a voltage, and that is being converted by a transducer. So that transducer is actually giving a 4 to 20 milliampere signal. On this 4 to 20 milliampere signal can travel long distance on the 2 wires, and it is being received by the PLC card. PLC is a controller which is going to receive it back. So this is the way it works. Now moving to the next slide, this is very, very important. Okay, why we use only current, we don't use much of a voltage over there. The first part is that voltage, as you know, that it gets degraded. The voltage drops on the long run because of the resistance of the wire, impedance, and all those affecting. So whenever that is a problem, automatically the signal gets degraded. So you cannot run 0 to 10 volt for a very, very long distance. In the VFDs, we do have 0 to 10 volt primarily with the potentiometer. So what we do is we have a potentiometer on the door of the panel, and just like maximum 1 meter of the wire, which is local wire, which goes to your VFD. So in the VFDs, for potentiometer, people use it that 0 to 10 volt. Otherwise, majority of the places you will find 4 to 20 milliampere coming. Now the current, what it does is it has nothing to do with that particular resistance. Current stays. It's the same loop. In the same loop, the current will keep on moving further. Second is voltage is very, very susceptible to the industrial noise. Industrial noise means voltages. So if you have a cable which is having a voltage of say, which is just a minute, which is having a voltage of say 24 volt. Okay. Another, you have an electrical cable which is having a bigger voltage like 230 volt, 240 volt. It is going to create a field around that conductor, and your 0 to 10 volt signal will be totally disturbed. That is called the electrical noise. Now for the current to change, you need to have a very strong EMF, number one. That is one reason. Second thing is you have to add that current into that particular loop circuit, which is practically not possible. So voltage can be affected from the electrical noise from outside, but current cannot be. Last is, since accuracy is a problem with the voltage for a long distance, you can never guarantee that the measurement is going to be accurate. So what happens is you are putting an instrument for accuracy. Now that accuracy gets deteriorated because of the distance. So this system itself is not accepted by the industry. So people move into the current transmission, and that is called the 4 to 20 milliampere. So this is the way that things move for milliampere. This is the reason that we have majority of the industry going in for 4 to 20 milliampere. this is the way it works. If you see on the long range, you will see the proper signal is getting deteriorated for voltage transmission. But as soon as you move into the current transmission, it remains almost at the same. It is not going to getting degraded because of the distance. So if there is any noise coming from outside, if there is any kind of voltage, EMF coming over there, the current is rarely affected over there. Okay. Moving further, if you have any questions, you can keep on asking because we have got very few people in the room. So no worries, we can answer all of your questions. Next is, this is very important, that defining the scale. Now you have got 4 to 20 milliampere signal that I have told you. Why not we have a 0 to 20 milliampere? This is the question also people ask me, okay, why don't you have a 0 to 20 milliampere? You have got 4 to 20 milliampere. It's a very simple. If there is a pipeline, you have put a pressure gauge over there and it is exerting a pressure of 0 to 10 bar. Okay, so the dia will be 0 to 10 bar deal. I'm going it, but I want to convert it to electronics. So it is going to send the data. So whenever the pressure is at 0 bar, automatically the 0 ampere is going to come and my PLC should be able to read it. This should be the normal question that people do it. And this is the normal logic of putting the signal. So instead of 4 to 20 milliampere, we can think about going in for 0 to 20 milliampere also. That is the way. But this is not the case in the industry. Moving to the second slide, if you see, this is the reason that we always use a 4 to 20 milliampere. Because on the left side of the image, if you see, if there is a 0 milliampere coming, means there is no flow or there is no pressure. Definitely the 0 milliampere will be there. But if the flow is coming, but there is no signal, like the wire has broken, still my PLC is going to read 0 milliampere because there is no current coming. So the PLC cannot distinguish between an empty pipe and a severely some instrument is bad or cable has gone bad or something like that. So I will not be able to do that. To remove that particular ambiguity, what we do is we always start the scale from 4 milliampere, never from 0. So this is going to help us that we should know that the cable has broken, there is a problem. Okay. So what happens is immediately 0 milliampere tells us that there is a fault. Immediately the PLC knows that there is a failure of a sensor and we are able to handle that problem very fast. Now 4 milliampere, if the 4 milliampere is coming, means the system is healthy, some signal is coming, but media is at 0 bar. So it will stay to 4 milliampere and maximum we have got 20 milliampere that we program it accordingly. So this is the way. So this is the important that live 0, and now live 0 here is at 4 milliampere. It is not at 0 milliampere. So live 0 at 4 milliampere, and if the 4 milliampere is coming, means the signal is healthy. Very simple, very simple to understand. I hope it's clear. If somebody has a question, you can just ask on that. I'm here to answer that. Now, next part is that 4 milliampere signal has got another benefit. Okay. What benefit 4 milliampere is? It is having some kind of a current loop moving. Okay. It is not 0 milliampere. So still I can find other methods to put in that 0 milliampere can be defined or it can be found. But we, as an industrialist, we always use 4 milliampere, and the reason for that is this. What happens is there are instruments who are giving some signal for milliampere, they need a power supply. So we give a power supply from outside. So those instruments are called 4-wire instruments. 4-wire instruments means the transducer need an external power supply of 230 volt AC. And then they give 2-wire supply, a signal output in the form of 4 to 20 milliampere. That is normally the old electromagnetic flow meters used to be like that, because electromagnets need to be very strong. They have to be very sensitive. So they used to have a power supply of 230 volt AC because it's an electromagnetic, electrical AC has to go through that. And the coil was being energized using an AC electricity. But the electrodes used to give signal back to the electronics, and the signal was coming as 4 to 20 milliampere. Now, imagine you have got thousands of those instruments in the industry. So what you have to do is you have to put thousands of power cables also to those instruments, then thousands of the signal cables also running back to your instrument. So that is another problem that is going to come up over here. So what designers did was that they chose that 4 to 20 milliampere to use the power also to give those transmitters. So the transmitters receive very minimalistic power, but they are able to give you an output signal. So these devices are called loop power devices. Means the signal, the two wires which are going to give you a signal, they are also going to, the power, they are also going to be used for the power. So both are. So you have got only two wires. Both the wires are going to give you the signal also, and they are getting the signal back also. The power also, and the signal back also. This is the way it works. This is the beauty. After the two-wire system was developed, most of the instrumentation has actually moved into the two-wire system. You talk of pressure transmitters, temperature transmitters, they have moved into the two-wire system. Now, this is another thing that if you are putting some machines or you are having some signals which need more than that, okay, they cannot be. So what you do is you simply, based on the calculation that this is the current wire requirement over there, so we don't make them loop powered, we put an additional power for that particular device. So electromagnetic flow meter is one of the instruments which needs external power supplies in some configuration. So most of the water supply departments, where they have ETPs, they always use 4-wire systems. But as soon as you move into like pharma companies and all that, so they have got like transmitters, they have got pH, conductivity, TDS, they all run on 2-wire because they are very near to that and they need very less power consumptions, and they do it. So you can define the power being used or needs to be consumed by a particular device. As soon as you find it that is between the limit of 4 to 20 milliampere, you can use a 2-wire device. If it is exceeding that, then you have to move into the other device. So threshold is if the requirement is more than 4 milliampere to power it. Understand that. Slide is very clear. If you need 4 milliampere to power it, this is perfect case of 2-wire. But as soon as it's more than 4 milliampere, means in any case, more power will be there and your signal will never be accurate. So you have to change it. Now moving to 4 to 20 milliampere blueprint, the final slide over here. First of all, why we use the current is purely that current is immune to the voltage differences. It is not going to drop like voltage for long distances. And it is not very well disturbed by the electrical noises so easily like voltages. So that is one reason of going in for a current. Why 4 milliampere is that I simply touched on the topic of live zero. Live zero is always 4 milliampere. That so that I know that my device is healthy, there is no broken wire, I'm getting that particular signal. That live zero is called 4 milliampere. And why 20 milliampere is it? It's basically to keep it within the safe limits. So after 20 milliampere, there is no current coming up from that device. So the PLC will be saved. From the PLC, the 20 milliampere is maximum going, nothing more than 20 milliampere is going to go to that device. So these are the limits that we have actually created on this. So do we have any questions on this that I have touched on this? Guys, if you have any questions, you can just let me know. I'm happy. We do have like 5 minutes more for this webinar, so we can answer some questions or any feedback on this. If you have any feedback on this, what I'm going to do is I'm going to put a request for feedback in the chat box, and you can give me that feedback via link also. So this is a link in the chat box. So you can just click on that link, give me a feedback that what more you want in these kind of webinars to be covered, what kind of things that you feel can be improved for you or your friends that I can add that is going to add value for you. I hope you had an interactive session. If you have anything more, you can just let me know. just take 2 minutes and give me the feedback, please. Apart from this, I have my own YouTube channel. So you can just go to YouTube. You can just Google me. You can find out me. And you can also subscribe to the channels, share it with other people that this gentleman is giving lots and lots of inputs on the instrumentation and automation on that. So it is helping the people who can reach more. So it will be great that you can help me out to do and that. And I also need you people to give me a Google review also, because Google review also help us to reach more people. And it will be great that if you can give me that also, so that I can keep on adding value and people looks at that Google review, and your credibility also improves based on the Google review, and people help you to reach more people. That will be great. Anybody wants to unmute and give me some feedback? So I have got some feedback also. Thank you very much for that, sir. And it will be great that your feedbacks will be helping us to move further and do lots and lots of things. And I'm very, very sure that this kind of the efforts that we are trying to do is not only for a general industry, but we are trying to create a revolution, a community of the people who are actually the real givers, and helping all other engineers, fellow engineers, to grow together, learn together, and have a very, very great manufacturing setup. So I take leave now from you. Thank you very much for your time. It has been pleasure hosting you. We'll be meeting every Saturday, same time, 3 p.m. Indian Standard Time. We'll be always covering one topic. And if you have any topic in your mind you want to discuss, or any problem that you have in your mind that you want to discuss, feel free to send it to me directly. My name is Manmeet Singh Bhatti. My Gmail ID is also manmeetsinghbhatti@gmail.com. My website is also manmeetsinghbhatti.com. I'm always the same. So you can get in touch with me and just send me the details wherever you want. We will be incorporating everything in our next webinar. Thank you very much. Jai Hind.